So, since today is a delayed opening, I wanted to still put the lecture material online that you guys are responsible for, and I highly suggest watching this before next class on Thursday. So, where we left off last class was we talked about the carbon cycle, we talked about fast and slow carbon pathways, and then we talked about how humans are releasing greenhouse gases into the atmosphere. Now remember, greenhouse gases aren't a bad thing. Without them, Earth would not be warm enough for us to live in it. However, since humans are burning fossil fuels and doing other activities such as eating cows and farming rice, we're releasing greenhouse gases such as carbon dioxide and methane into our atmosphere. Now, these additional gases are increasing that greenhouse effect and making Earth warmer. Last class we started talking about what the effect of increased greenhouse gases is, and I had already mentioned that it's going to cause the average temperature of Earth to warm. Now, it's not making it warm up, 10s and 20s degrees. It's, first of all, global average. It's increased by about 1 degree Fahrenheit, and although that doesn't sound a lot, today's temperature is only 8 degrees warmer than it was during the Ice Age. So small changes in temperature can have a huge effect. Over the past 10 to 15 years, we've seen some of the warmest temperatures on record. We began talking about this slide last class. So an increased temperature is really going to affect how weather occurs across the globe. So one thing that's going to happen is that some areas are going to experience more drought, while others are going to experience more rain. And the reason this is that when it's warmer, evaporation happens more. You guys have seen this during the summertime. In the summer, you'll notice that it's very humid because warm air holds water, and that's what humidity is. So, in areas that are already dry, such as our deserts, there's already a lot of evaporation that happens. Well, with it being warmer, even more evaporation happens. Well, that water has to go somewhere, and even without global climate change, that water gets pushed to temperate regions like where we live and to tropical rainforests. So if more water is being sucked out of deserts and out of dry areas, they're going to experience more drought, and that water is then going to go to other regions that already get rain, so they're going to get more rain. Now this can really severely affect agriculture regions. One, if you're going to have more droughts, you're going to ruin your crops, and uh, crops can drown too. You can have too much rain, and that can also ruin crops. Very huge storms, like hurricanes that we experience here on the East Coast, will increase in severity. Typically, it's because there's more evaporation, so there's more water vapor in the air. It's also warmer, and that's what fuels hurricanes. So they're going to become more severe. It's also possible that we may see a higher frequency of hurricanes, meaning that you're going to see them more often. Now, this doesn't mean every single day. It just means that, instead of having 10 in a season, maybe you'll have 15. Another effect of increasing greenhouse gases is linked closely to the increase in global temperature. Scientists have noticed that the ice caps, so the North Pole and the South Pole, are melting, which makes sense. If it's warmer, that ice is going to melt. Well, the water that was in that ice has to go somewhere, and it ends up going into our oceans. This picture on the left is showing a glacier, so here in 1928, and glaciers are remnants of the last ice age. They're huge packs of ice that haven't moved around for thousands and thousands of years. But you can see after about 80 years, this glacier is mainly melted, and it wasn't like this before, so all of that water goes somewhere. Now, it's not like we're going to see a foot of sea level rise next year. So far, they've seen that in the past 10 years, the ocean has raised about 3 centimeters, which is about 1.5 inches. So if we were to say 100 years, times that by 10, that's 30 centimeters or about a foot. So if the sea level continues to rise as it currently is, we could see in 100 years the ocean's about a foot higher than they are today. Now, a foot doesn't sound like much, but most cities along the coast are only a few inches above sea level. And nearly 5 million people in the United States live less than 4 feet above high tide. So that's a lot of people that could potentially be affected. The last major way that increased greenhouse gases are going to affect planet Earth is the effects of warmer weather. As you know, insects, especially mosquitoes, come out during the summertime or during the warm months. Well, if Earth is getting warmer, that means our warm months are going to be extended, meaning there's going to be more insects like mosquitoes and ticks and a whole slew of other insects. A lot of these insects, like that tomato hornworm we watched a video of, is going to damage agriculture. So you have more insects that can now feed on more crops. You're also going to see, such as with our mosquitoes and ticks, is that since we have more of them, they're going to spread disease a lot easier. There's tons more mosquitoes that we'll get bit with that are going to transfer diseases between humans and between other species. So as you can see, greenhouse gases are going to increase the temperature on Earth, which is going to have a whole slew of other effects. Now again, this isn't going to happen overnight, but we've already started seeing these changes. For example, the insect populations have changed so much that scientists are now starting to notice that in bird migrations. A lot of birds around the world are starting their migrations earlier because they're following insect populations. They'll move back into those colder ranges where they flew away from because now there's food there. So these effects are already being seen. As I said, they've already measured sea level rise. Granted, it's not a lot, but it definitely has the potential to increase over the next few decades. Now, I don't want this to sound all doom and gloom, like there's nothing we can do. You definitely can. Each individual person can easily reduce the amount of greenhouse gases that they're releasing. And this is really important because if you're not really reducing your emissions and I'm not reducing my emissions and no one is, this trend is going to continue. You may think it's not that bad, but it is. And the environment takes a while to respond. Even if we stopped all of our emissions right now, we could see that maybe we'll still see an effect on the environment. The environment is not going to react immediately. We could release 100 million metric tons of carbon dioxide tomorrow, and the environment is not going to change overnight. There's a lag time. So even though maybe these effects don't seem that bad now, they will become even worse. Now, if you don't think that this is a big deal at all, or you could care less about the earth, or you don't care about carbon dioxide and releasing it, fine. I can't change your mind there, and that's okay. However, all of these ways that you can reduce your greenhouse gas emissions are also going to result in you saving money because the things that use greenhouse gases, such as burning fossil fuels, cost something. So if you're using less fossil fuels, you're going to save a lot more money. So one of the major ways that greenhouse gases are being released is, first of all, carbon dioxide is the one we release the most, and it's released from the burning of fossil fuels. So with transportation, you know that cars and buses take gasoline, and that's a form of oil. You burn that gasoline in the engine, and you're going to release carbon dioxide. So the kind of transportation you take is really going to affect what or how much carbon dioxide and greenhouse gases you're releasing. So let's go through an example. Here we have two students, they're at home and they need to get to school. So one thing that they can do is they can take a car. And this car is going to follow this whole path all the way to school. Now, cars have different efficiencies, meaning they can burn gasoline and it'll get them to go, so many miles. You'll hear the term miles per gallon or MPG. And if you've ever seen a car commercial, they usually refer to MPG. That's saying if you were to put a gallon of gas in your car, how far would it get you? You could have a very fuel inefficient car, meaning it doesn't do very well. So for instance, you could put a gallon of gas in your car and it only gets you 10 miles. So 10 miles per gallon or 10 mpg. Or you can drive a hybrid or something or an electric car or a really fuel efficient car that gets 50 miles to the gallon. So that means that every gallon you put in your car, you can drive a lot further. You can drive 50 miles per gallon in your car. So let's take an example. Let's say this entire route is 10 miles. And this car that they drove to school gets 10 miles per gallon. So if this car just traveled 10 miles, so again the route is 10 miles, and the car itself gets 10 miles per gallon, that means that this car burned 1 gallon of gas to go from home to school. Again, this route is 10 miles long. This car gets 10 miles per gallon. So if I asked you how many gallons of gas did this car use, you would say it used 1 gallon of gas. Now the importance in this is that no matter what kind of car it is or anything, if you burn a gallon of gasoline, that's about the size, or that releases 20 pounds of carbon dioxide. Now that may be kind of hard to imagine because obviously you can't just, get a bathroom scale and weigh carbon dioxide. A pound of carbon dioxide is like one of those exercise balls. So if you go to the gym or you've ever been in a gym class, they usually have those really large round exercise balls. That's about 1 pound of carbon dioxide. So for every gallon of gas you're burning, you're releasing 20 exercise balls filled of carbon dioxide. So you're actually releasing a lot of carbon dioxide every single time you burn a gallon of gasoline. So let's go back to this scenario. We have a car. It drove 10 miles. We burned a gallon of gas because we know this car gets 10 miles to the gallon. And since it burned a gallon of gas, it's going to release 20 pounds of carbon dioxide. So these two kids released 20 pounds of carbon dioxide to get to school. Now an alternative is you could get a better car. So if you were to get a car that got 20 miles to the gallon, that means you traveled this whole 10 miles and you still had 10 miles to go before you burned a gallon of gas. So in that case, you only burned half a gallon of gas because your car can now go, let's say, 20 miles. Your car can go 20 miles to the gallon, but you only went 10, so you used half a gallon of gas. Since we used half a gallon of gas, that means we only released 10 pounds of carbon dioxide. And I encourage you, since this is a video, pause this at any time, rewind it, replay it, work out the calculations to make sure that you understand these concepts. Okay, so that's one alternative. You could get a car that's more fuel efficient, that burns less gas. Another thing you can do is rely on public transportation. So the bus, great form of transportation, but the miles to gallon it gets is probably close to 10. They're not horribly fuel efficient, and that's okay. So let's say it gets 10 miles per gallon like that first car. It's going to go the same path. It's still going to go this 10 miles, So it goes 10 miles, it gets 10 miles to the gallon, meaning that it burned a gallon of gas. 1 gallon of gas